welcome. This session will cover top 5 ways to authenticate applications to Google Cloud that don't include downloading service account keys. My name is Busan. I'm a cloud consultant based in South Korea. Here today with me is Shaun, a product manager for Workload Identity and Service Accounts based in Sunnyvale. We'll start by introducing service accounts and service account keys. Then we'll talk about the right way to authenticate applications. We'll end by discussing best practices for managing service account keys. I'll cover the first section and Shaun will cover the last 2 sections. Before I talk about service accounts, I'll clarify what's in scope for today's session. First, when we talk about APIs in this session, we're referring to Google Cloud APIs specifically. Authenticating to other Google APIs, like the Google Maps platform APIs or the YouTube APIs, may work differently. Second, this session is focused on programmatically authenticating application code. Third, this session is targeted at beginners. We'll focus on the common cases. The goal is to give you an overview of the available options. Our documentation goes into much more detail on what to consider and how to use specific authentication methods. Now I'll introduce service accounts and service account keys. Google Cloud APIs require every API call to be authorized. In other words, APIs require calls to identify who is making the call. This feeds into audit logs, quota, and billing. There are 3 ways to authorize API calls. First is API keys. This only identifies the application. API keys are a string of letters and numbers. API keys aren't an option for the majority of APIs, but APIs that support it include the Natural Language API and the Translate API. Second option is a user account. This is an end human user accessing resources. An example might be me creating a Google Compute Engine instance through Google Cloud Console or gcloud. The third option is a service account, which is an identity that represents a workload or an application. Application code is most likely using a service account. Again, service accounts represent an application or compute workload rather than a human user. A public-private RSA key pair is used for authentication. There are no passwords, so you can't log in as a service account via the browser. Service account identities also don't belong to the Google Workspace domain. There are 2 types of service accounts. The first is a service account that you make for your own applications. There are also default service accounts created when you use certain services. For example, when you create a compute instance in a brand new project, the Compute Engine default service account is created and attached to the instance. For your production workloads, we recommend you create custom service accounts tailored for the workload rather than relying on the default service accounts. When using a service account, you have the option to download a service account JSON file. This is the private key for the service account. However, we don't recommend downloading key files if you can avoid doing so. That's because there are some risks associated with using service account keys. The first is credential leakage. Consider the scenario where a developer accidentally commits a key to a public code repository. A bad actor can get access to the resources in your environment using that key file. Second risk is privilege escalation. If a bad actor gets access to a service account key, they might be able to use the key to escalate their own privileges. For example, the bad actor could use a service account with permissions to Google Cloud Storage bucket to give themselves additional privileges on the bucket. The third risk is identity masking. When a bad actor acts through a service account key, they can conceal their identity and actions since API calls are recorded as having been made through the service account. The main takeaway of this slide is that anyone with a service account JSON file can make API calls as that service account. Since you now understand some risks of using service account key files, Shaun will share how we recommend you authenticate your applications.
Thank you, Busan. As explained above, there are a lot of risk and security issues related to using service account keys. We are seeing a lot of customers and developers who are authenticating with these keys when they should be using alternative methods. Today, I am going to focus on these alternative methods, as well as what you should consider if you must use a service account key. Because there are multiple ways to authenticate to Google Cloud's API as an application, we built out a flow diagram to help you decide on which method to use based on different situations. We will first go through the diagram before jumping into the details of each of the authentication methods. The first question that you always need to ask yourself is whether your application is running on Google Cloud or not. This is the first part of the flow diagram. If the application is running on Google Cloud, then you want to check, are you trying to run your application on GKE or outside of GKE? For GKE, there is a special feature called GKE Workload Identity, which is a simple way for you to federate in your Kubernetes service account to get a GCP access token. If it is not on GKE, then we have two methods. If you're doing development work in local environments, then we recommend gcloud auth application default login. While if it isn't running in local environment, then we recommend attaching a service account directly to your compute or serverless instances on Google Cloud. Shifting to the other side of the tree, you want to ask yourself, if your app is not running on Google Cloud, is it possible to set up federation? You are able to set up workload identity federation for workloads running in other cloud as well as on-premise, as long as the cloud providers or your on-premise deployment have the ability to generate an ID token. If that is not possible, then you are left with service account key, which should be the last resort. I will spend the last part of today's session going through a few methods you can use to secure your service account keys. But before going there, I'm going to go a little more detail into each of these authentication methods. The first method I want to focus on is gcloud auth application default login. Most folks who use gcloud are familiar with gcloud auth login, which allows you to log into gcloud via the command line. This is very similar to gcloud auth login. However, instead of signing in to run methods on the command line, this will generate a user credential for the user who is running the command. It will then automatically put the credential in the well-known location for application default credentials for the client library, which means as long as you use client libraries in your application to make requests to GCP API, it will automatically fetch this credential and use it to make requests to GCP API. This is very secure and time-bound credential, which is perfect for local development. Note that in this case, you're not even using a service account. You're just using the credential of your user login. Now, if we move away from local development onto workloads on GCP, including serverless products like App Engine, Cloud Run, Cloud Functions, or compute products like Compute Engine, then the best and only way you should be using to access GCP API is using attached service accounts. When you create a GCE VM, most times, as Busan mentioned, it will automatically come with a default service account. We recommend you to create a service account based on applications that you are running and replace the default service account with this new service account. Not only will the attached service account grant the application ability to authenticate without using a key, the custom created service account will also make sure you adhere to the principle of least privilege. When it comes to calling GCP API, you can similarly use the client library exactly like in the previous slide and in the previous example. And the client libraries will help figure out how to retrieve the service account and its permissions to perform the API requests. We are seeing a lot of developers and customers who are using service account keys for this scenario, especially because the legacy tutorials floating around on the internet tells people to do so. Please make sure to never use a service account key when running on any of these GCP services. If instead of other GCP resources, you're running your workload specifically on GKE, we recommend you to go check out GKE Workload Identity. The process is streamlined, and all you need to do is enable GKE Workload Identity and make sure that you have configured your Kubernetes service account inside your clusters. GKE Workload Identity will automatically exchange your Kubernetes token for a GCP service account token in order to authenticate as that GCP service account. Once you set this up, you should be able to allow your workload to directly access GCP APIs. Finally, for applications running completely outside of Google Cloud, for example, if your application is running on AWS, Azure, on-prem, or GitHub, GitLab, we recommend you to use Workload Identity Federation. As long as your workload has the ability to generate an identity token for itself in its native environment, Workload Identity Federation allows you to exchange the native ID token for a GCP access token. With the GCP access token, you will be able to impersonate a regular service account and its permission without using a service account key. This is very similar to the GKE Workload Identity flow. The only difference is that you will have to set up the federation pool yourself based on whichever cloud provider or SaaS service or on-prem service that you're trying to integrate into GCP API. If you're using our client libraries, most of the credential exchange flow is fully automated and taken care of by our client libraries. Workload Identity Federation is very popular and much more secure than using service account keys. We have put in a lot of effort to make the experience more seamless for our customers. Recently, we added integrations with gcloud, GSUtil, and BQ CLI to enable more use cases with these federated identities. For customers who have apps running on-premise with on-premise identity providers, we also launched SAML support, as well as the ability to retrieve IDP tokens via a customer-defined executable through the client library. This is very important, especially if you're trying to connect your on-premise application to GCP API. That is because each of your on-premise identity provider might have different ways in which to retrieve the credentials, and allowing you to write your own executable will dramatically simplify the process of retrieving the credential and exchanging it for a GCP access token. Now that we went through the recommended authentication methods, there are still scenarios where you must use a service account key. And for these scenarios, I'm going to give some recommendations to help you best secure your service account and your service account keys. First of all, you should prefer to always upload keys over downloading service account keys. This is a native feature attached to service accounts. You can use your own PKI infrastructure to generate a public-private key pair and deliver the private keys securely to your runtime environment. Public keys, which on the other hand are less dangerous to be handled and passed around, can be uploaded to Google Cloud. This way, there's less chance for error when it comes to handling and passing around private keys. Secondly, for scenarios where you need to access GCP API from non-production applications, for example, if you have an intern building a proof of concept, or you're manually triggering some jobs to retrieve data for your data SaaS services, we recently previewed the ability for you to set up expiration time on your service account key. Configuring expiration at the project, folder, or organization level will make sure that any keys generated under that container will automatically have a key generated with the expiration time attached. Note, however, that we don't recommend key expiration in production environment, as it is very easy for developers to put that into the code, and when it expires, it leads to outages. And that is something that we want to help our customers to avoid. To prevent outages, I want to finally talk about key rotation. And this might be something that you might have heard about before, but what you want to make sure is that every developer in your organization gets in the habit of rotating these service account keys due to all the security risks that we discussed. Using tools like Cloud Asset Inventory, you'll be able to track down when each key has been created. You can then build custom toolings based on your organization structure to trigger notification to development teams to go and rotate these keys. You can configure these notifications to get louder over time if they're not acted upon. Alternatively, you can test out tools like Terraform Vault, which will also help simplify the process of rotating these keys. Although the process is complicated, if service account key is a must in parts of your organization, we highly recommend you to set up proper rotation policies to prevent any security issues linked to these service account keys. Long-lived service account key is one of the biggest issues when it comes to cloud security, and we hope this presentation was useful for you and your organization. Thank you, Busan, for joining us today, and thank you all for listening and helping to think about how we can together make the cloud more secure.